Hello, hello, hello. Welcome to the stream. Let's see here. We're going to go through and test out my other cameras. Hey, that one's working too. Wow, that's working. It looks like it's all working. That's crazy. That's going cool. So, what should we do tonight? Well, let's see here. Last stream, we were working on the AC power distribution down there, and we found some things. So I do know that I still have one of the contactors to work my way through because the NC contact on that is in a relatively high impedance state, so we're going to take care of that. And then I've also got what we discovered with the circuit breakers not being screwed onto the bus bar, which was concerning. So we're going to be also taking care, well, maybe taking care of that. I might just replace those breakers. I might look at them. Like I don't really know where they were arcing internally if that heated them up excessively. So I think we're gonna look at and evaluate that and then keep working our way through it. Unlike previous streams, I think I've done a decent job of getting the computer all set up right from the get-go here. So that's great. Let me just check my storage, make sure we're not gonna unexpectedly run out of storage because that's not what we want to do in the middle of the stream. Hey, plenty of space, cool. So, shall we? Move some of our lighting around, and yeah, let's get going here. There we go. Cool. Gonna move y'all from this tripod over to my other one. Let's throw our screen share up on the good old TV. Choose some content. Mirror this. It's there, look at that, magic. Okay, let's do this. I should set up controls on my iPad for OBS. That would be very convenient. Get that camera situated. There we go. Hello. Welcome to the stream. So, wow, look at everybody in the chat there. That's great. Okay. So, last stream, we rebuilt, or cleaned, and kind of rebuilt, I guess, this contactor, the normally closed side of it. We rebuilt that one. So if we, because it's normally closed, we can just measure the resistance across that without doing anything too fancy, like pushing. Well, yeah, pushing a contactor in is not that fancy, but you get the idea. So let's check that out. So we get very low resistance. But then when we do the same measurement on this one, come on. It's not great. It's like, it's all, in fact, it's pretty bad. It's all over the place too. And then if I switch to the low ohm range, which runs a little bit more voltage through it, so we get a more accurate resistance measurement at this very low range. You know, it is lower when you send some more current through it, but it's still not what it should be, and it's still, you know, all over the place. So that's suboptimal. So we're gonna be starting probably with that contactor, and then you know, the last stream we also found the issue with our bus bar here. So this bus bar was used to connect the power to all 4 of these circuit breakers here, and this breaker here, the number 3 breaker, which is for the roughing pump, the bolts in it that attach, secure the contact to the bus bar, they weren't in like at all. So let's see if focus is going to behave. So we can see the pitting and arcing that happened on L2 and L1N right there, those two. So that wasn't great. And the roughing pump was also the largest inductive load, so not a great one to have this issue with. But yeah, let's let autofocus take back over. So I think we're gonna go ahead and start with this other contactor here. Seems like a good place to start to me. And I think we're actually gonna start with the label maker, because labeling stuff is just gonna make this, well, let's see here, what do we got? Who do we got to pull out? Oh, those are already labeled. It's also pretty obvious where they go. So let's get those pulled out. Let's re-level y'all's world here. Well, that actually got this most of the way out. That would have that would have been an easy way to start doing this last time. That's kind of funny. We really only need just this one out for now, so those wires will also pull out. Oh, that's kind of cool, the way that it sandwiches wires on both sides. So you, of the contact. So you kind of have the wire either on the bottom of it or the top of it. And because of how the screw mechanism works, which we will see here in a second, you can kind of put it on either side. So that's neat. So those are free. Let's see here. This is a good wire to label here. That one's not labeled. So I'm going to grab the label maker. What should we do? Heat shrink labels? Heat shrink labels or cable flags? Heat shrink labels can kind of rub off, but they're also pretty cool. So I'm going to go grab some heat shrink labels. Let's do heat shrink labels. We'll grab a couple different dimensions of heat shrink labels. Let's see here, it's going to be HS, HS, HS. I think I have some OEM one, don't I? Oh, I have some big heat shrink label. That's fun. Okay, 0.88, 11, I think the 11 millimeter will do just fine for our purposes here tonight. I don't think we need the yellow one. I think the white's gonna be what we wanna use, so yeah. Okay, heat shrink label. Nobody in chat has opinions about heat shrink labels, I'm shocked. Okay. And then we're also going to get the charger out for the label maker, because I do know the label maker's a little bit low on charge at the moment. I think it will not reach. Fastest way to do this. We probably got enough for one charge. We will plug this in now, though, so that we can get it charging once we're done with this first label. Let's move this somewhere I'm less likely to step on it. If you have him using, that's a good approach to label. I mean, that's a good approach to labeling in general. Okay, so we're gonna be labeling the, what is that one? That's K1? Yeah, that's K1. So we got our label maker here. Let's get all of our settings right for heat shrink. Here, what font do we want to do? I think we'll just keep it standard stuff. I think it's LGO. And size, we'll go auto, width, auto, style, bold, alignment, looks good. Then, let's see here, what size do we want to use? You know, we got a lot of different sizes. Let's do smallest that will fit's usually a good approach. I will also need to get a heat gun out to actually shrink these. The 8.8 should do a pretty good job. I mean, I wonder why they use the yellow on the other ones, but I got the white loaded in, so we'll just do that. So this is going to be K1, here, nope, that's pipe. Semicolon, do I have a slash on the front panel? Probably not. No, I have it right there, okay. So that's gonna be K1 slash 20, K121. Text too large, I thought I set that to auto. Nope, I did not. Auto. Oh, it's not what I thought. Oh, okay, I want LGO. There we go. Then I'm also going to be labeling, let's see here, K122 as well. Can I get this free more somehow easily? I can. Look at that. Go on. There we go. Okay, so that can kind of. Well, let's get that a little bit more. There. Now that can sit down without pulling on anything too much. Okay, so there's K121. Man, I am very tempted to pull these 4 wires off, but they kind of go through a inductor and into a connector. It's kind of a pain. Yeah, we'll just bring this up here to work on it. I mean, now I have access to take the whole box off if I wanted to. I don't know how much that would help. Heat shrink labels are so satisfying. Okay, so this is K121. That's definitely what we're pulling off. Grab our driver. Okay, so K121. Challenge is always getting them to open up. There we go. And also we're going to find out if I made it big enough, because I know I made it big enough to go over the wire, but I didn't make it big enough to go over the anti-chafe cover on it. And I didn't really. So my options are either, well, I should go up one size. I'll give myself another 5 or 10 seconds of struggling with this, and then we'll decide. So you can see, big enough to go over the wire, not big enough to go over the anti-chafe sleeving. So that's a thing. Okay, bigger size. So let's see here, that was 8.8. So let's step up to 11.7. We'll try the AHS brand out, and if that doesn't look good, we'll grab a another one of the BYZs, because the BYZ ones are actually pretty good stuff. Okay, got that loaded in. And then let's do 21. Then let's also do 22. We know we're gonna need that label as well. Okay, so we got 21 printed. Oh, look how nice and big that is. I like that. Okay, so this is definitely 21. So that's gonna go over that real easy now. There we go. And we're gonna heat shrink this once we kind of get this back together more, because that way I can kind of orient them all in the way that we want them to be oriented. Okay, so let's pull the other side of this off now. So this is kind of a short wire actually. So that's the wire we're gonna put our 22 label on. Okay, what's our next label we're gonna want? We are gonna want a, I mean, I don't technically need to label that one. Oh, we're gonna replace this duct tape label, so that's gonna be, it's gonna be K1 T1. It doesn't spit out the one that you're going to use until you've like cut another one, just because of kind of like how far away the blade is from the cutting, or from the cutting blade is from the label tape cartridge. That's kind of my only complaint with this label maker actually, is that, oh, it was labeled. I didn't realize that. Look at that. They actually labeled the wire itself. Wow, that's fancy. Oh, my camera's drooping here. Oh, okay, let's bring that back up. Look how fancy they were. That looks like, I don't know, laser, inkjet, I don't know. It's on there pretty well too. Isn't that cool? Well, that's K221 on that side, and this is K122 on this side. I already made the label, so I might as well slide it on, but it's labeled already. I would have almost thought that was like factory labeling on the wire, but the factory labeling on the wire is black. Look at that. Isn't that cool? Yeah, that's actually, most of these wires are labeled. Okay, that's convenient. So we're just going to pull out the contacts for... Yeah, so the Joel did cable labels. These are wire labels. You know, these are individual conductors. This box is built by a third-party contractor, so it's a bit different, you know. Let's see here. Okay, so order of operations on this is you take the cover off. Oh, actually, we got to pull those at the bottom, so we're going to pull those two out. Come on. Oh, you're really in there. Oh, this one's got the duct tape labels on it. Love that. So there's another jumper we've kind of pulled out that we'll be reassembling. And then we can pull this whole thing off. So it just pushes down, bottom folds out, then that comes out. So we still got two conductors holding on to everything else. And then we'll pull the cover off. Those in our screw bin. So the cover will come off because we don't have any cables in, and some of the contacts fell out. That also happened last time. Let's see here, we'll just screw these ones on so they'll stay in place. Put that other one in the bin. Oh, we lost a camera. We'll get that in a sec. Then we can pull out the coil contacts. So that's the coil contacts in there. We got that whole thing free. It's not electrical tape. I'm pretty sure it's duct tape. It's either duct tape or like gray gaff tape, but it's got like a weave in it, and the adhesive is certainly as bad as duct tape. So, this microscope did come from Singapore, so it's probably Singapore's equivalent domestic version of duct tape, we'll say. So we got our contactor we're going to work on out. Instead of trying to do all this on the ground like I did last time, I think I'm going to bring a cart over and just do that on the cart. So it's going to be a bit easier as I kick my label maker. Let's put the label maker on the charger. Huh. Something has gone slightly wrong with one of my studio light fixtures. Doesn't want to retract properly. Interesting. Let's turn the light on so you can see what I'm doing. Or let's turn the camera on so you can see what I'm doing. So it's the spring inside of this one. So the spring inside of this one's kind of acting up a bit. I am dealing with some stored energy here, so I want to be careful. So it retracts okay, but it feels like it's got insufficient tension to pull it back up. Yeah, we need to turn that some. Okay, that's doing better now. Okay, I like that a lot more, but that part's also kind of gotten weird, so let's get that readjusted. No, I think I'm just gonna leave that part how it is for now. It's up and out of the way, there we go. Okay, let's bring a cart over so I got somewhere to work. Oh, one of the wheel locks is on. There we go. So let's pop this camera up in the air some more. Let's pop this one up in the air. Kind of keep it a bit wide and bring the center column up. That'll keep it more stable. I think I need to refill my little bottle of alcohol. Where's my Everclear? Probably where the Everclear is supposed to be. It's approximately where it's supposed to be. I'll count that as a win. And the VOC meter is certainly going to spike after this stream, or during this stream, but anytime I use Everclear, the VOC meter goes up quite a bit, actually. And like all of them do. Doesn't matter where they are in the building. Give our work surface a bit of a wipe down. Oh, there's some goop over here. It's coming right off though, cool. Okay, there we go. We got a clean-ish work surface. Let's pull a chair out for it while not rolling over any of my camera cables. There we go. We got a new setup. Oh, there we go. That'd been more entertaining for you all if I had that camera on air at the time. I'll switch back to the triple view. I even framed everything pretty well. Gonna utilize my adjustable studio lighting here, which is why I got it. Hello. Oh, I had the knee pad out since last stream. Okay, so let's see here. First thing we need to do to get into this is to separate our halves here. Let's make this a little bit higher up. Try not to accidentally tip it over, but we'll get a bit more of a top-down view going. And I could go even higher too if I wanted to. Maybe we do want to go higher. You know what? I have a good idea that'll be worth the second it takes to set it up. So I can split this off this way, and I can actually do a pretty much an overhead camera setup, actually. That's going to require that I extend out the tripod legs a little bit more, though. So let's bring that back in first so I don't tip it over in the process. Lock that down. Manfrotto Magichrome would be really nice right about now. I feel like I do enough stuff that I want an overhead shot. I should have just like a dedicated overhead shot cart for this. That's a pretty good overhead shot. Look at that. Okay, so that is... Okay, so to separate these halves, we need a flathead screwdriver that I very conveniently have here from the last time I did one of these. Wow, autofocus is really feeling it today. Okay, let's just lock the focus because this is going to be kind of the same thing. If I wanted to, I could put it in manual, which maybe I'll do, and then we can, yeah, I'll do manual, and then we can extend our, ISOs all the way up. Let's bring that down a fair bit. And then we can close our shutter down, and that will substantially increase our depth of field. Okay, do I have an exposure meter? No, I don't. Okay, UPC mode is weird. That looks approximately properly exposed. Okay, there we go. I might be able to reuse the existing stuff. It's a little bit wobbly, you know. It's made to move around quickly, not necessarily be stable. My idea was kind of lights on the ceiling, cameras on the floor, but you know, we can adjust that. So I make this pretty convenient. You just gotta like push down and twist a little bit. They even give you a piece like to push on when you twist. I don't want to break it. So I got that side popped. We'll get this side popped. There we go. So we got our contactor split open here. So this side's the coil. So this and this are the tubes that our coil contacts go through. And then you can see the coil, or the coils down in here wrapped around each side of our core. These are the springs that move the contactor up and down, and this is what gets pulled into the coil when the coil is energized. So there we go, we got that out. And then this part comes out pretty easy. And then the place that we want to focus on is our contact right here. So this is our NC contact. So when this is, I want some more lighting. So when this is pushed out by the springs, right, this contact right here gets made. Let's kind of see it right there. Here, I'll really get you a close-up. So the one you see being broken and made there, that's the one that is contaminated and has rather high impedance. So to get the top part out is relatively easy. Or the traveling part of the contact that's mounted via the spring. That's pretty easy. It just, you kind of got to just rotate it. There's some kind of grooves it's in. So you rotate that sideways, and that comes out relatively easy. And I'm going to try and maintain good control of the spring so that it doesn't shoot across the room. Hey, I got the spring out. Yeah. So with the spring out and the contact itself rotated sideways, we should be able to pull the contact out now. Being careful not to grab the contact surfaces themselves with the tweezer. There we go. So that's the contact itself. And yeah, it's pretty dark. Let's throw a macro lens on and we can, y'all can visualize it easier. Let's see here, 100 millimeter macro or 35 millimeter? Let's do the 100. I like the 24 to 100 lens. It's pretty flexible. I like how small it is when it's at 24. Minimum focus distance is kind of far, so that could be slightly better. I'll set that over here. Let's angle this one a bit better. So there's our contacts there. Okay, we're still at f10, so that should improve our depth of field compared to last stream. But it's autofocus is being autofocus, so let's do this manually. Oh, that's focus range. There we go. There's manual. So you can see we got a fair bit of discoloration on these contacts. Definitely lines up with how high the resistance on them was. Oh yeah, look at that. I mean, it's certainly seeing crustier, right? But this is a pretty low current. It's just 24 volt DC, right? It's not like it's the contactor that all the power in the mix was going through. So let's get our burnishing tool out. So we're going to clean the grooves out first. So I think I got those pretty cleaned out. Oh, one of them's got a bit of crud in it still. Okay, looks like we got those cleaned out. So now we'll do our burnishing on the top surface. Well, we can show that to you first. So there's the side we cleaned the grooves out on versus the side we really haven't yet. Pretty big difference already. Okay. Head in the way of the burnishing shot. I'm sorry, I was wondering if that was going to happen or not. So now we've done the grooves, we're doing the top surface. Okay, almost got my way through all of the gunk. How about now? Yep, I think we've pretty much got it all. That's looking pretty good. Come on. You must know you're not focused. Like, it must be pretty clear that you're not focused, right? Do I have too much faith in autofocus here? I have way too much faith in autofocus, apparently. So there's it with the grooves fully cleaned up. And there's the other one. Autofocus is EB. So pretty big difference. And it's what we expect for hundreds to thousands of ohms of resistance, right? pretty big difference, I'd say. Okay, on to the next. There we go. Now I'm actually going to do the top surface first this time. Oh, this one's taking a little bit more to get through. Interesting. Well, there's some more pitting on this one. Interesting. Focus, maybe? Start down here and get closer. Switch it in real quick. Come on. Please, please. Oh, wait, what's my range set to? It's set to full. It should be fine. Should be absolutely fine. Well, manual it is. So you can see there that there's still that kind of that one dark spot remaining. So there's a little bit of uneven wear going on. Because that spot is much lower than the rest. So that's interesting. Okay, so we're pretty much through everything on the top layer now. I don't know why I expect this to work every time. So the other side, this side, that's the one where we haven't cleaned up the grooves yet. Yeah, I mean, like contacts on like really high current stuff, like that stuff's those are gonna be just blasted away, right? These are doing low current service, but this low current, relatively low voltage, and it's control signaling, right? So that makes them more sensitive than higher currents like these. I just don't think this isn't the right contact for this type of work. I'm gonna try cleaning the grooves out with the tweezers. So I don't know how that's gonna go. Oh, that's working really well. Surprised at how well that's working, actually. There we go. Yeah, that worked out really well, actually. Still gonna hit each groove once with the burnisher in each direction. Cool, got those grooves clean out, and then we'll just do the top surface one more time. It's looking pretty good. Cool. We'll wipe this off with the ethanol one more time right before we actually put it in. So we're just gonna move that off to the side for now. And now we need to extract the contacts from this. So now that we've got the thing out, oh, those look worse on that side. Wow. Okay. So those are the other side of the contacts. They're not looking much better. So to get these out, been using these. Just been grabbing on, locking it down, and pulling it out. There we go. So that's one of them out. I feel like, and let's see here, the switch breaks the circuit between the thermocouple and the valve. Huh? That. Yeah, I bet they don't. They're not. Standard light switches are not made for 1 volt. That's for sure. Wow. Just compare the color on the ones that I've cleaned up versus the opposing side that I haven't cleaned up. And this will also be pretty good at showing the difference in direction of the two. Yeah, look at that. Like that one gets too shiny for the, or it's too reflective almost. I'll go straight on. Yeah, look at that. Wow. This is much more comfortable to do at this little table than it was to do on the ground. Okay, so that's what it looks like. So that's with just the grooves cleaned out. So there's still some low spots we got to work our way through. Kind of see it on the bottom one, what, second or third from the left, kind of a low spot there. And the second one from the left, also some low spots. I mean, there was all of that goo, you know. You gonna feel like working at some point? There we go. That's a really low spot on that one. There we go, we're through it now. Except for one little spot, which we might not be able to get all the way through. Okay, we're looking pretty good now. There we go. It's looking pretty good. We'll do our last pass to kind of put the finish we want on it. And I am intentionally leaving the center the highest point. Kind of trying to reduce the amount of contact area instead of increasing it actually, because that's going to increase the contact force quite substantially. And in these conditions, that's going to do better, I think. Yeah, we'll do a bit more cleaning of the grooves with the tweezers. Okay. Yeah, it's looking real good now. Check that out. Cool. We're going to get this completely cleaned up. Well, part of me wants to make sure I put it back in the same side. But I also want to get this kind of cleaned out more overall. So I'm going to pull the other one back out. And they are the exact same, so it doesn't really matter what side we put it on. Yeah, we're going to pull the other one out now. So that way once we get all these out, we can get... Oh, I don't have it focusing. So we're going to pull the other one out now, and then we'll get this cleaned up, and we'll put this one back in, and then we'll finish cleaning that one out. So this is the one that goes on the, looking at it, and the orientation it gets installed in goes on the top. So we're going to pull the bottom one out. We're going to set that aside. And we'll be able to tell which one's which right now because one of them is very discolored, and the other one is not. There we go, we got that out. And yep, it's pretty discolored. Okay, so now we'll get this all cleaned out, and then we'll get the one that we finished reinstalled. Magpie stream, yeah. It's all about the shiny. Shiny, usually, there's very few cases, I think, in electron microscopy where you don't want shiny. I'm trying to think of what those would be. When would we not want shiny in electron microscopy, at least in the microscope itself. You know, your sample is a different story, right? But frequently you want shiny with the sample too. Okay, this is pretty much cleaned out now. Just gonna go blow it off real quick. Then before we go any further, I'm going to go ahead and check continuity on all my other contacts to make sure those are in good shape. So we're going to push that down just slightly. We don't want to, I'm going to put about the same amount of force it would have on it normally. That's a little bit higher than I want to see. Oh, pop that one out. Okay, well, I guess we can inspect it. Oh, okay. We're cleaning these two. These are pretty, these have gotten dirty. Okay, we've got a bunch more contacts to clean. These ones will be faster though because they're flat. This is also the older of the two contacts. The other contact was much newer. So I guess it makes sense that this one's going to have more issues. So yeah, we're going to be cleaning these two. Yay! Oh, these ones have got some pitting on them too. There's some pretty deep pits, so we're not going to get all the way through the pits on these ones, but we are going to get it cleaned up quite a bit. And then this one's kind of got a curve kind of going this direction on it. Curve's kind of going this way, so we're going to kind of maintain that by doing our burnishing in the same direction. Okay, that's looking pretty good. We got a few pits left, but again, we'll be taking a lot of material off if we're going to go all the way through the pits on these ones. So there's where we're at with that now. Substantial improvement. You kind of see how it's got that little bit of a bow front to back. All right, a little bit hard to see on camera, but it's there. Okay, let's pull another one out. Okay, we got all the retention, cable clamps off. So pull that out. Yep, that looks pretty bad too. It's not, well, again, the contacts can be gone, and that's, you know, different. So pull the springs out. So there's the spring, pull it out. Oh, we're not focused. That was I think that was some like adhesive or something on the side. I did see a little bit of something on the side. Oh, that's the melt zone from the spot welding. It's just very shiny there. So that's normal. That stuff on the side. Okay, so we got the spring out. Now we'll pull, so we see we got that contact and that contact out, so now we're going to pull the middle part out. So we need to rotate it 90, and then it'll come out. There we go. Hello, welcome to the stream. Yo, yo, yo. Just in time to see some more ugly contacts. Three-phase contactor. This microscope behind me is EMO box, emergency off box. And there was some goo in the box, and we think that that's contaminated all the contacts, so we're getting some high contact resistance. Okay, so let's see here. These are also bowed the same direction, so we'll maintain that when we burnish them. And it is a three-phase contactor, but we're only using 2 of the phases because this is not a three-phase microscope. So 755. That's a microprobe, right? That's that one's got the high pressure oil coolant loop in the objective lens, if I'm not mistaken, right? The Joule microprobes are very fun, I think. XRF. Oh, what's the three-letter, like, so like, I mean, the SEMs are JSM for Japanese scanning microscope, and then the TEMs are JEM. Oh, it has the XRF. Okay. Does it have the WDS on it too? Well, wait. So is 750? So is it a oh, what's the microprobe? It's JAMP is auger. Is it JMP? Oh, what's the three-letter acronym for Joule microprobes? I don't remember. It's not JWS. That's all my brain wants to say is JWS, but that's the wafer system. And GEM, JEM, that's already TEM. Yeah. It's the 3 letters they put before the model number. Is it JMP? I think it's JMP. So TEMs are JEM, which is Japanese electron microscope, and then SEMs are JSM, which is Japanese scanning microscope. Auger probes are Japanese, JAMP, JAMP, Japanese auger microprobe. So I think just the regular microprobes are, JXA, yeah, that's it, JXA, you're right. $733. That's that is $733 is a microprobe. It's an SEM. $733. What age is that tool? I think is that like an 80s or 90s tool? The pitting's worse on this side. They cut the HV. Oh, okay. So you gotta do some cable work. You can depending on how much room you've got and where they did the HV cable cut, you can pretty easily pot those, like pot the connectors back together. Take like a metal box, terminate the ground shields with a metal box, and then pot the innards. Yeah, I've made HV cables from scratch for the Joels before, doing silicon casting on the for the terminations and stuff to make the like cones and whatnot. It's pretty fun. I'm loading down my burnishing tool here. Highly recommend a platinum cure silicone for high voltage work. That definitely works out better than two-part silicones. You're really assured that you've got a full cure when you do a platinum cure. A lot of two-part chemistries are sensitive to like 3D printed molds too, especially resin 3D printed molds. They don't like to cure all the way, which we don't want. Oh, we lost the battery in that camera. Oh no. Okay, let me get another battery out. Mark's multiplier and oh, you need the whole HV tank? Oh, that's a lot of, okay, that's a bit more work than just the cables. Okay, I need to look up what a 733 is real quick. It is a microprobe. Yeah, 733 is a microprobe. Okay, it's 840 era. Yeah, I thought that was a microprobe. Yeah, okay, that does have the high pressure oil coolant objective lens. Oh man, you're gonna have fun with this system. You definitely need to make sure the high pressure oil coolant loop is intact. That can take your system down. It's a lot of PSI it runs the oil coolant on that platform at. They used a very tiny objective lens, so they run a lot of current through it in a really small space, so it needs a lot of flow. And they also wanted to they didn't want to dedicate very much space for the cooling. So they used the high pressure oil coolant. So there's a water to oil heat exchanger on it. Yeah, you do need to run nitrogen through your proportional detectors so those are WDS wavelength dispersive analyzers. Explain more about the high pressure oil. Okay, so you've got like a power supply box. Well, it's like the box that the AC power comes in. I think the AC power comes in that box. But you've got the roughing pump. You've got the oil heat exchanger and pump thing, and then you've got the air compressor and that like the pancake. I think it's a Mitsubishi air compressor. And so that kind of that like it's like a rectangular box that goes behind it. So that oil. Let's see here. Can I find a column cross section? So that oil runs through the objective lens. And then so the other reason the objective lens is so weird, is such a weird shape on that, is the microprobes, like they have a lot of beam current. Like they will ablate away samples underneath them. So you tend not to use the beam to focus. You just use the beam to analyze. And so there's an optical microscope built into the objective lens, and that takes up a lot of room in the objective lens compared to what's in the objective lens of a normal SEM. And so to make the objective lens fit in that highly constrained geometry, they have the oil cooling jacket and tube on it. The crystals are moisture sensitive. Dry nitrogen can protect them. An XRF module. We say XRF, like so XRF is X-ray fluorescence. IXRF, which is a specific company, makes a the IXRF, which is a specific company, makes a XRF system for SEMs, which is kind of weird. Are you referring to the EDS, the energy dispersive spectrometer? So EDS is usually added on a microprobe. So because the WDS, wavelength dispersive, which are the big like wings on your system, those can measure a wide variety of, or those measure not a wide variety of X-rays. And to scan the whole spectrum, the whole crystal, has to like sweep its whole arc. So you throw an EDS on the front, energy dispersive spectrometer, so that you can really quickly kind of get an acquisition, know what's there approximately, and then you can tune your WDS spectrometers to the wavelengths that you care about that you saw on your EDS. Because WDS has much better sensitivity, much better peak resolution, and for a given energy, very, very fast acquisition time. So microprobes are commonly used to make maps of large areas of samples. That's why they have such high beam current, so they can get really large amounts of signals. So yeah, those crystals do need to be kept dry. The crystals are swappable. Yeah, so the objective lens. So it's got that optical microscope built into it, and because the optical microscope is built into it, and you need room for the optics and to have a large enough objective bore diameter, and so simultaneously you need room for the optical optics, the electron optics, and the WDS spectrometers need to also have a clear shot at the sample because of the takeoff angle of the sample. Given all of that, given all of that, you have to have a conical pull piece so that the X-rays can make it from the sample to the detectors all around the edge. You have to have an optical microscope, and you have to have the electron optics. Highly constrained space for your optics, so they needed a way to get a lot of heat out. So the high pressure oil coolant is also high flow because they didn't want to dedicate very much space for the cooling channels. Yeah, it's such high pressure that it can burst. And if it bursts and leaks in your chamber, that's a pretty serious cleanup job. Not a fun time. So definitely want to check all your connections and whatnot on that system. Also want to make sure your oil stays dry. I don't really know what else you do for preventative measures on keeping burst objective cooling loop from happening, but you have 2 columns, so you've got spare parts, so that's good. So you're missing your high voltage tank completely? Okay, so we got this contact cleaned up pretty well. So compared to what that was previously, we're looking pretty good. See, it kind of maintained the same shape. Okay, so you're missing both your tanks. That is suboptimal to be missing both of your tanks. electron microscope tanks are not the easiest thing to make from scratch. The stability requirements are really high, like very high. Any change in voltage you'll see as a change in focus. Also curious what you want to do with the platform. Microprobes are very powerful. They're also kind of specialized. Like if you want to be doing chemical analysis, like they're an amazing tool for that. But if you want to be zooming in really far, they can. They're not really made for that. So yeah, the optical microscope. So inside the objective lens, basically they're using like mirrors as optics, I think, on that platform. And the mirrors are all first surface coated, so they're all coated with metal, so they're conductive. And then there's just a hole in the center of them all, like kind of like a telescope, you know, like if you have like 80% of the area of your mirror reflective, even if you don't have the center part of the mirror there, there's still plenty of information there to like form your image from. And then you put your sample in, and then you adjust your sample's height up and down until it's at the point where the mirror's focus, or where the optical microscope focuses on it, and that gets your sample at the perfect height, so that you know your electron beam is also focused to that height. Because when you set up and adjusted your microscope, you set up and adjusted your microscope. You made sure that you set your objective lens on the electron beam to the same point. Yeah. Van de Graaffs are also very, very much not stable. And then, yeah. Van de Graaffs are way, way higher voltage you need to. And then you also still have to, you need to have your filament power supply as well. Like you're like floating on top of your high voltage. So you still need an isolation transformer as well. Yeah, Van de Graaff into Leyden jars is not going to give you anywhere near, you're many, many orders of magnitude off of the stability you would need to be able to focus the image. You're looking for like part per million stability on the output of your supply. Okay, so we can just compare what some clean contacts look like from some dirty contacts. So yeah, I'd say they look a little bit better now. So do you have the microprobe because you want to do chemical work, or do you have it because you want an electron microscope, is the real question. A change in voltage as little as like 1 or 2 volts is going to show up in your image changing focus. So if you charge a cap up and then you let it discharge, your image is going to be like changing focus the entire time. And the microscope will basically be unusable because all of your other alignments also kind of change as your focus value changes. So if your beam energy is changing, like all of your alignments are constantly shifting. And it'll be exceptionally challenging to resolve an image. And the electron beam itself, like, yeah, as you said, we'll bleed it down. But if you're going from 30,000 volts down to 0 over the course of 5 or 10 minutes, like you're going to be you're never going to have enough time at any to like actually get the beam focused and adjusted. I mean, you'll be able to zoom in a bit, but like your image brightness and contrast is requirements are going to be changing. Your stigmation value is going to be changing. You're going to have to constantly be adjusting the objective lens. Yeah, so that's and that still doesn't solve the problem. No, a 1 or 2 volt change at 30 kV will show up. Your image will like change focus with as little as a 1 or 2 volt change. Because a stronger electrons of more energy are lensed less or deflected less by your lenses than electrons with less energy. So as the energy of your electron beam changes, how your microscope is focused is going to change. So the high voltage tanks are like in the control console on that microscope. So there's just like an empty spot in the control console still. It's a big empty spot. That is unfortunate. That is very unfortunate. You might be able to find other power supplies. I mean, you can like there's a number of power supplies that you could make work. One thing you do have going for you with a 733 is that a 733 is an old enough system that it doesn't really, like one part doesn't really have something to do with liabilities, man. You need to figure out like where it was, figure out where the microscope was, and like try to email these people and see if they still have the tanks around, because that's going to really help you out a lot if you can get the tanks. You can get tanks off other microscopes and make them work. I don't know how good you are with digital electronics, but if you get a tank off of something like a 840, 6400, it's possible to drive those with basically like just an FPGA and Arduino. You just need to drive some like digital pins. So 733 is a pretty good microscope to be changing a tank out on. One hand of the microscope doesn't really know what the other hand of the microscope's doing. So because of that, so because one side doesn't really know what the other side's doing, it's not really going to care per se if you put a different high voltage tank in. A lot of microscopes are very heavily integrated, especially newer ones. And if you're missing like the entire tank, like the software will like refuse to start. But in your case, the rest of the microscope will be fine starting with the high voltage tank. So that's good. In fact, I almost wonder if an 840 tank would be just a drop-in for your system. Do I have 733? I may have 733 schematics. I can look at that. Do you have schematics as an instruction manual with your instruments? Yeah, the tank is a similar generation. The beam energy on a microprobe usually goes up to 50 kV, so that's a bit different, but you don't really care if you go up all the way to 50. So if you can get up to 30 or 40, so like an 840 6400 tank goes up to 40 kV, you're gonna be doing pretty good. So yeah, driving one of those is a little bit of a digital controls project, but it's not terrible. It's one that I am going to be doing at some point, but I don't know when some point is. I've got other projects that are first. But controls for existing Joule tanks is certainly something I am very much working on. And I do think there's some tanks on eBay right now too. Okay, this one's looking, I think, about as good as I'm gonna get it. I might try cleaning out the divots a little bit more somehow. Joel's warehouse is in Illinois. Who would you reach out to at Joel? Like sometimes they do, or I think this past time where they cleared most of their surplus, that generation microscope parts out. Okay, so we got one of the AC contacts cleaned up. Let's check out the next one. Well, you know what? Actually, I think we're gonna reinstall this one first. Yeah, let's get this one reinstalled first. So we're gonna do this in the reverse order. Well, actually, we're gonna clean these off with alcohol first. Let's get a fresh wipe out for this. It's on GitHub. It wasn't Kickstarter. We've been doing pre-orders. We've got another batch just about done here, actually. And I think this batch will pretty much clear my pre-orders. But it's on GitHub, so it's open source hardware, so you can just download it yourself and make it. It does involve quite a bit of SMD work. It's a bit tight, so having a reflow ovens definitely makes it a lot easier. Yeah, it's called the Open Beam Interface, OBI. So if you just look up Open Beam Interface, the GitHub repository will come right up. I'm going to clean the pits out on this side too. So we'll be doing some development streams on Open Beam interface as well. Maybe some manufacturing streams, who knows? Okay, so got those cleaned out, so we'll hit that again with the burnisher. A microwave magnetron. Well, you don't need a microwave magnetron. That is way, way more power than you want to be dumping into your SEM by a lot. So this microscope here actually has a plasma cleaner on it. It's kind of around the front. You can't really see it right now. It's like 20 watts, like tops. That's about what you want to put into these things to plasma clean them. I would not dump a magnetron in. I mean, there could be vacuum leaks, you know. Vacuum leaks do just develop. That's something that you kind of find out once you turn the system on, but I would not anticipate most O-rings being damaged. Most of the O-rings are fine. If you do have vacuum leaks, it's probably gonna be like one O-ring that might be a little bit too squished or might have a piece of dust on it. The magnetron's not gonna be happy operating at that low. Really, you just, I mean, if you look at plasma cleaners and SEMs, they're a bit different. And your system, your system is also diffusion pumped. Diffusion pump systems are harder to even use plasma cleaners on. I would not anticipate the chamber needing to be cleaned out as like the primary issue with the microscope. If there's dust and large debris in the chamber, that needs to be like wiped out. But worrying about like hydrocarbon contamination is somewhat far down your list on that particular platform right now. Yeah, you just don't need magnetrons on this thing. You can just get like an RF, like any RF source, and just like have a coax cable going into the chamber, and just like have just like a chunk of like exposed coax in the chamber. That's probably going to do a better job than like a magnetron. Of course, you're going to need a matching circuit on that too, but yeah, you do not want to be dumping that much power into the column. And then getting a magnetron to like seal onto the microscope, well, because the microscope also, you need to operate at, yeah, well, I mean, getting a magnetron to seal onto the microscope while it's under vacuum is going to be exceptionally challenging. They're not made to operate. They're not made to operate at atmosphere or at vacuum. They're made to operate at atmosphere, right? Yeah, anything ham radio, you can get a really cheap RF source, but yeah, your lens coils are outside the vacuum. The diffusion pump is dirty. Yeah, okay, so the diffusion pump, you're going to want to clean all that out. It's probably a SantaVac 5 platform, so you're going to need new diffusion pump oil, or you can probably replace the SantaVac 5 oil with just Lioness. You can get either of those from Ted Pella or similar sources, like EMS. So Lioness, LOIN-S, is a lot less expensive than SantaVac 5. But yeah, basically just like use a green scrub pad to clean up your diffusion pump. It's pretty labor intensive. If you can bead blast it, that works too. Okay, that's all cleaned up, ready to install. So we got that inserted. So it's 90 degrees right now. So we'll get it lined up front to back, and then we should just be able to rotate it 90, and it should pretty much just fall right into place, which it did. Hey, look at that. That was not hard at all. Yeah, L-I-O-N-S. I think I said that wrong. So yeah, just scrub off all the crud. Yeah, diffusion pumps tend to look like that after many years of service, so that's not surprising at all. Okay, we're getting the spray installed now. We'll go ahead and wipe the spring down real quick too. So you can see he's putting the spring in there. Okay, I will get that other camera turned back on as soon as I am done inserting the spring, because I don't want the spring to fly off on me. Which it just about did. So that was just about to turn into a spring hunt. You're going to have to kind of collapse it to get it in. But that is just asking for problems, but I've done worse. Oh, almost lost it. Yeah, Slava Ukraine. Well, congrats on it being your Friday. Okay, still haven't got it in. Man, I had such high hopes for this being easy to get back together because it came apart so easy. Okay, there we go. Got it halfway in. Yay, there we go. We got it all the way in. Okay, cool. God, even just looking at the back of it, it like kind of looks a little bit cleaner. It's probably hard to tell on camera though. Maybe you can see it. I think there's a slight color difference between that one and that one. So yeah, I think the hardest thing in your... yeah, I believe standard K-type filament should work in it. Yeah, I think your biggest obstacle on that thing is going to be your high voltage tank. But you can focus on getting vacuum and everything else ready before you work on the tank if you want to. But yeah, you should be able to basically swap in a pretty wide variety of tanks. And just like any electron gun controller, well, not any, a lot of electron gun controllers should be able to be substituted in. FEI made some back in the day called the like 1LE or 2LE. Those should work. They might not be as high voltage as you want. Might be, well, I mean, they'd be high enough voltage to get an image. The microscope was running when it was deinstalled. This was sold as a working microscope for a lot of money, like a lot of money. So like the roughing pump was running off of those unscrewed connectors. So that was not great, but yeah. Okay, we got this cleaned up, so let's get this installed. Okay, I got that in. Output feedback control. Yeah, so there's a measuring like a measuring resistor network, and so it's a closed loop feedback on your output voltage. So that's part of it, and the other part of it is preventing any kind of like discharge, like corona discharge or arcs. Because corona discharge or arcs will cause like a voltage dip because you can't supply infinite current to keep up with the current draw. So that's why tanks are commonly in oil. It is possible to have it be stable at with just air insulated, but you have to have a really solid design. But yeah, closed loop feedback is the way. Okay, got that all cleaned up. So let's put that back in. Okay, let's get our other one that we're going to clean out apart. So our third one should basically, well, actually, you know what? Our third one should basically be unused. I could just take the unused phase and move that to the phase we're going to use, because we're only doing line and neutral, right? We're not doing three-phase. Let's see how the unused phase looks. I bet it's brand new. It's pretty much brand new. So let's look at the phase we are using. Okay. That looks not great. I think we're gonna swap these around. Any reason not to swap them around? I can't think of any. I think that's gonna be our plan. We're still going to resurface these a bit because they do have some kind of wear just from kind of opening and closing a bunch. I don't like putting the bad ones back. I'm gonna clean the bad ones up really fast. Just so they're do a 80-20 clean on them, or probably less than 80-20. I'll just hit them real quick. Well, have fun dealing with your cats. Yeah, definitely pop back in. Meow, would you like to throw a link to the SEM Hackers Discord into the chat? It's a great Discord server where a lot of people have electron microscopes. And there's a ton of people there that you can ask for help anytime. And I would highly, highly recommend that you get in there and start talking about your microscopes and posting pictures up, and people can absolutely help you source some spares and whatnot for it. Meow, I will enable you to send links, because I think I need to do that. Or I can just post a link too. Congratulations, you... Yeah, you have been upgraded to a moderator. I think that's enough. Well, this is worth getting a Discord account for. This is an amazing community. And they're going to be able to provide an astonishing amount of assistance with this effort. I highly, highly recommend joining. Very much worth it. I cannot understate the amount of assistance you can get on that server towards getting your platform online. Yeah, it's like, I mean, it's a community of like, what, 30 electron microscope owners at least, like people in their garage who have got systems in absolutely awful condition and got them going. It's definitely worth hopping on there if you haven't been on Discord before. You see I got contact all over my fingers now. I think somebody has, I know there's at least, I'm pretty sure there's at least one Joule microprobe in there already too. Don't remember quite what model it is off the top of my head. Okay, did a quick job cleaning up the two that we're not going to use. do a better job cleaning up the two that we are going to use. I think I'm wearing my burnishing tool out. Nice. Not surprised. There's something on this unused one that's actually like being harder to clean off than the used ones. That's interesting. Huh, unable to accept the invite link. So okay, yeah, that's my name. And then unable to accept. Okay, that contact's looking good. Let's get this other one cleaned up. Okay, let me take a look at the link settings real quick. If you want to, If you want to, you can post your Discord name, and then I can invite you just by typing your name into the Discord like invite window. Yeah, if you just post your name, I think I can invite you pretty easily just within Discord. I think Shift Enter. Names aren't necessarily global. It's like it has to have like a unique identifier after it. It's just like a number or something like after if you copy it from certain places. But it's trust me, this community is worth doing Discord for. I have gotten some very old people who don't really computer very much onto Discord because of this for this community. Absolutely worth it. Only place like it on the internet right now for working on electron microscopes. And I would not underestimate the power of community for being a motivating factor in getting projects done. Well, you know what? The microscopes usually run code written a lot earlier than that, so you're applicable experience for working on these platforms. I don't even think the 733. Yeah, 733 has a I think it's an Intel 8080 in it. Okay, I got a pair that are good, cleaned up. So now let's grab the other side out of here. Get those springs out. Get these rotated 90 so they'll pop right out. Okay, come on. There we go. Well, if it's any comfort, I'm quite certain you won't be the oldest person in the Discord. And I'd say that the technical Discord communities certainly differ from the other ones. Here, I'll post a link to my Discord server. So the SEM one is not my server, but I have another server that I created many years ago. I can post a link to. And that one, I'm pretty confident the link will work. And if you join that one, I can invite you to the other one from there. There we go. So I'm putting the burnishing on my, or the burnisher on this microfiber, so that can kind of like deflect and adapt to the shape of the contactor a bit. Okay, I should be able to do this a bit faster this way. Oh yeah, that's getting through it faster. Cool. Oh, that's good enough for the one that we're not going to use. The URLs expire after 7 days. So I highly recommend using them sooner than later. I'll tell you what, I'll put my Discord username in the chat and you can just add me as a friend. Is that you that I see in there? Azure? Join. So that's my name on Discord. But it looks like you might have made it into the. You have a Fox for a profile picture. Hey, okay. Or, well, it's either you or somebody else who's watching the stream. Let me find the. There's a way to copy my username that has like the number on it. But Discord's in this weird streaming mode thing. So I need to disable streamer mode. Yeah, there we go. Okay. So how do I copy it with the number? Oh, they got rid of the number thing. Okay, well, welcome, Azure. But yeah, if you can figure out how to get your Discord account verified, it's a pretty great community for electron microscopy. Is the microprobe that's under the Joel channel, is that a 733? Under the Joel section there? Hey, look at all the unused contact burnisher underneath the heat shrink label. Okay, there we go. Wow, this thing really has been worn out by this. This is funny. Oh, I can feel the difference in what it feels like to. I don't know if the burnisher is diamond or not. It might just be textured. Yeah, you can see the difference in how worn this is. See, I peeled the heat shrink back some. That's funny. I know they only say JSM, but I think somebody might have put the wrong name on one of them. Oh yeah, no, you're right. Yeah, okay. I thought somebody had a 733 for some reason. Maybe that was somebody who was on Twitter. You know, but like these are especially soft contacts, so I think it just might be the amount that I'm wearing through. I don't know. A little bit surprised that it's failing in this way. Yeah, silver. Interesting. Yeah, these might be silver. That would make sense. Maybe I'm just clogging it up. I don't think so. I think I'm wearing it, but I don't really know. Huh. Wonder why. Interesting. This is not a file. This is a contact burnisher. This is made to resurface contacts. So not quite a file. A little bit more fancy than a file. Okay, that almost looks as good as I want it to. Okay, that should do. Those are the two we're not using. These are the ones we're using. Okay, these all look good now, so we'll get those cleaned up and put back in, and I'll show you all on camera first. Look at all those nice and shiny contacts. Well, good news. If you're the type of person to be messing around with host files in the way that you are, you're also the right type of person to have an electron microscope. So you're doing great. Okay, let's get these reinstalled. Well, we're gonna clean them off first. Okay, I got that all cleaned up. Let's get that installed. Okay, that's in. Now I gotta put the spring in, which is definitely the harder part. Get the spring cleaned up first. You're in! Welcome, welcome to the chaos. Okay, let's get the spring in. Oh, there's definitely some tricks to this. I'm doing this. It seems like I'm gonna get this one done a lot faster than the other one. Yep, and we're already in. There we go. Cool. Okay, these really aren't that bad. Well, welcome to the chaos, meow meow. Oh, cool. That one was not as bad to put in. Okay, that battery is dead. Let me grab another battery. I really should get the AC adapter for this camera too. It'd be great if this camera could be powered over Type-C. It could be from the right type of connectors, but... And then go ahead and throw a message in the introductions channel. You know, throw some pictures of your microscope in there too. And somebody will make you a dedicated channel for your microscope where you can post pictures and info and whatnot about it. I think that, yeah, introductions channel should be on the left there somewhere. Vacuum club didn't work. Okay. Other meow. Do you want to see if you can post a link? Because apparently my links are just not working tonight. I set it to only expire after a week, so I don't know why it would time out already. That's weird. Maybe it expires after number of clicks, not just number of actual invites that are accepted. I don't know. Okay, get that in. Cool. Let's get another one in. Okay, let's check resistance on those now. We got those cleaned up. .09, there we go, and 0.09, we're looking great. Cool. 0.08. Cool, well, those have working better than they were. Yeah, we're not using this third phase, but I'll get it cleaned up anyways, just in case somebody switches it out later. Okay, let's see how fast I can get the spray installed this time. It's amazing how clean the spring feels after wiping it down with the alcohol and the microfiber. I can like feel that the surface is devoid of oils. It's great. Oh yeah, that feels clean. And if I wipe my finger over one part of it a few times, it feels less clean, so I'll wipe it off again. I need to get microfiber cloths that haven't been dyed. Or maybe it's I don't know. Because if it's like the polymer they use to make it is like that color, that's one thing. But I have seen some cloths where the dye does come off. But I've been using them more for even like cleaning like vacuum hardware, especially from the roughing pump side. And they're really, really effective. I'm quite impressed, actually. Okay, not as... Whoops. Oh, there it is. Okay, well, it didn't fly very far. It had to happen at least once, right? The spring flew off, but we got it back. We're good. We'll wipe it off one more time just to make sure. I bent that spring a little bit. Get that bent back into shape. Come on. I tried installing that one in the wrong one. That's funny. Okay. Well, I've been trying to do it kind of top first instead of get the base in first, but I'm going to go back to getting the base in first because that's what's worked. Oh, there we go. Okay, that was... Yeah, base in first is the way. That was pretty easy, actually, once I stopped messing around. Well, I got the third one in, but while putting the third one, I managed to knock the first one out. So now I gotta put the first one back in too. Okay, first one's halfway in. 3/4 of the way in. And all the way in. There we go. We got 3 springs in. So now all that's left is our contacts. So these 2 springs, these big springs here, these are the ones that open up the contact. And then these ones are pointed in the opposite direction because when you push this down, it kind of goes down. And then it goes a little bit further on the springs, and that way each of the contacts has its own spring that can kind of take care of whatever unevenness there is. But yeah, these big ones are what open in. And most of the contacts are in. 4 out of 6 contacts are in. I just don't have the set that we're not actually using in yet. So there's 2 sets of springs, and they kind of work in opposite directions. And the big ones have more travel than the small ones. Okay, now we're putting our 3rd set of contacts in. There we go. We got all 3 in, or all 6 in. Okay, so now we got all those in. Let's put the one that we actually came here to fix back in. And that's our smaller NC contact. And this contact is substantially smaller than the other contacts. So there's the smaller one that we got cleaned up earlier. Oh, look at autofocus worked great that time. So now we're gonna get our small spring in. Here's our smaller spring. We'll get this spring in, hopefully without launching it somewhere. And I launched the spring. Okay, let's not accidentally roll on it. There it is. I didn't really launch it, more just, well, I launched it a little bit. Okay, there's our spring. It is one of the, yeah, there's two basically identical contactors because for semi-standard, oh, what's the name of the organization? Basically, this machine was in a fab where it was before. AMD Singapore, in fact, is where it came from. And so it had to follow certain standards for semiconductor equipment, and one of those is that basically every part of your emergency off circuit is like double acting. So you've got two contactors like in series. So if one of them gets stuck closed, the other one's most likely not going to get stuck closed. But if the other one, oh, okay, that's probably actually what the NC contacts are for. If one of them gets stuck closed, it won't let you start it up again. So like the three main contactors are normally open, right? And then this one small one on the side is normally closed. Which actually, speaking of normally closed, I put this one on the wrong side. So you can actually just reconfigure this one on the side from normally open to normally closed, depending on how you install the contacts in. That's actually really interesting. So I need to be, that's probably why everything felt a little bit weird, or compared to how I took it out, is because I need to be doing everything from the other side. Oh yeah, this is gonna be easier. Okay, so that goes in like that. Nope, that goes in like that. Well, that would have been interesting. It would have been like, why is it open circuit? And it's, yeah, it turns out it can be configured either way. So that's kind of cool. Oh, I almost had it and then it shot back out at me. Man, we almost had it like 3 times there. Really struggling with this one. Yeah, turbo making horrible noises is a good reason for a shutdown. Microscope makes a bad smell. That's certainly a use for these for the emo. Say bad smell is actually pretty common. I mean, it's not that bad smells are common. It's that out of times that the emo is triggered, bad smells are probably a pretty common reason. And I'm having a time at it with this one. Come on. Oh, you're so close, you're so close. Yeah, I got it. There we go. Cool. Okay. That was fun. Dust on the CRT's load resistor burning off. Yeah, that's a smell that I know. Okay, so now I'm cleaning up the contacts for the NC contactor that we just installed. Yeah, that's the enthusiasm I should be having for getting the spring in. So there's our cleaned up contact. No, it's not out of focus. So that's our cleaned up contact there, and we'll get this installed. It's funny how much harder these ones are to insert than the other ones that take much higher current. There we go, that's all the way in. It's lining up well with the other one, so that's good. So now we can get our last one in, yay! So hopefully this repair is good for the life of the microscope. And I'm guessing these are in better shape than they were even from the factory in terms of cleanliness and surface condition. So I bet this will last a long time. Interesting, this one is already tarnished. The other ones didn't tarnish. Why did this one tarnish? Why did it tarnish already? That's interesting. Silver oxide, yeah, it would make sense. Maybe I touched it with my finger at some point, bare finger. Well, that was unexpected. Yeah. I should. I've just been handling them with like tools after getting them cleaned up. I've been using the tools to handle them. So I didn't really think I needed gloves. So it might be proving me wrong. My hands are pretty clean right now. I've been using the ethanol. The wall is so the wall is vertical slats, and then behind that is 4 inches of rock wool insulation. So it's an acoustic trap to make the audio in this room better for microscopes and for video. Because these microscopes are also microphones, it turns out, when you zoom in far enough. Especially, it turns out, especially certain models of Zeiss. Not particularly the one I'm working on right now, just other ones. Well, that's been all shiny-ified now. We'll clean it up again, see what happens. That was interesting. Rock wool is a pretty good wall, especially for acoustics. Well, that's looking pretty clean now. Nice. A dark room should not be that important. I have definitely used microprobes in well-lit rooms. A dark room is nice for the phosphor, like to see the CRT, but yeah, it's I have not had that be an issue during operation. There might be some kind of shutter built into it. I'm not sure. But yeah, or just a cover for the eyepiece. Okay, so let's get this one installed now. There we go. Now we get to test the contact resistance. I'm gonna switch lenses back out to a wider angle here. Just crackers. I wish it was cookies. That'd be good. But alas, I don't have cookies right now. So there's what we just spent all that time on. So that's our NC contact there. And those are our NO contacts. Well, I was munching, so I turned the audio off for a second. I have a little button that can do that. Okay, so let's check all the resistances here. So that's our NC, so that is closed right now. If I could touch the metal, that'd be great. Okay, now that I'm not touching plastic. Okay, 0.11, not doing bad. We'll cycle it a bunch of times, see what it does. .09, there we go, so that one's good. If I continue to touch the right part. .09, that's what we want to see. And then we'll go for all of our other three here. Well, this is the one that we don't care about, actually. But it's still looking pretty good when I actually touch the right spot. There we go. Oh, nope, not touching the right. Oh, I pulled the contact out. Okay, well, let me put that back in. Okay, contact's been reinstalled. These are kind of annoying to probe. .11. .09, .09. .09. Okay, cool. We're looking good on all of them. Love to see it. I'm going to thread these back on while I've kind of got it open like this. It's just going to be easier that way. Oh no. A lot of that's going to be the lead resistance and the contact resistance of the probes and the contact resistance in here. We can do a measurement with a different setting on the meter that will reveal even more. Let's see here, which way are those supposed to be? Let me look at the other one. Those are 90 degrees from how I have them. That makes sense. Come on, go on, please. There we go. Okay, now we got all these to put on. You can see how these things work. So this is where'd it go? Where'd the plastic housing for this whole thing go? There it is. So this is the housing that goes over this whole thing. And it's got these two holes in it, right? So you can put a wire in the top and in the bottom because the things that actually hold the wires on, you can see how they can have a gap on either the top or the bottom. And then it's got the actual contact piece of copper in the middle there. And so you can kind of see how that can go on top and bottom. Have I done any NMR work? I think I have answered a few questions for one person, for like an NMR scientist about something relating to like contacts on something a really long time ago on Twitter. And I've been in the room with NMRs, but I've not worked on NMRs. They're cool, just haven't worked on them. I was asked to inspect an MRI one time, but it was in like a mostly abandoned hospital because of Hurricane Katrina, I think, or something. I don't remember exactly. It was weird. I'm pretty sure it still had a field in it, and so I was like, I don't want to go in the room. I was like, well, your cryo compressor has pressure and is running. Your e-stop circuit has power, but I am not going to go past the line that says don't go past unless you are free of ferrous metals. And everybody, like the hospital administrators, are ready to walk past the lines. Like, I don't think you should walk past that line either. So that was fun. Look at that. There we go. So you can see our NC contact working there. And on this side, we can see our NO contacts working. So you can see that normally this would be pushed up, right? Or normally this would be pushed up by these two springs here. And that's what keeps it open. But then when the contacts close, they're touching right now, but there's not very much force being applied. So they're touching right now, but there's not very much force being applied to them. But then when we push down on them, that spring travel right there, that's the three springs that individually close each of the contacts. So anyways, I think that's ready to close up now. And yeah. It is a seriously rebuilt relay. I like whatever I work on. I'm a big believer in the model. It's not going to fail because of me or because of what I work on. So, and I've got evidence that this has been a failure in the past. So if I prevent, a day, more likely more than a day of downtime, it is well worth it. This is designed to be a high availability, high throughput tool doing automated continuous data acquisition on latest modern nodes of chips. So we don't want this tool to go down after we've commissioned it. Okay, so I got that all aligned. I got all my parts in there that I want in there. I believe I do. Just making sure that the core is in the right spot. It is. Cool, let's get that assembled. I was thinking about that too. It's very possible. It might also be some type of like short or snubber. Yeah, I'm not sure. Not an expert in contact design. That was a satisfying kerclunk. Yeah, so the customer purchased this microscope and shipped it directly to me for rebuild commissioning, so. I am not a master of the microscope arbitrage game. I have sold precisely one microscope. I have been involved in moving and relocating and being in the middle, well, kind of in the middle of deals, like, connecting buyers with sellers, and then the buyer usually pays me for relocation, rebuild, or whatever. But I've not purchased and sold very many microscopes. And the one microscope I did so at cost. And I was just happy to see it go to a good home. Someday I might probably get into microscope resale. It's a good gig if you can do it. I can see myself reselling microscopes that have upgraded. How did I fall into this line of work? Ben Krosno on the Applied Science YouTube channel. I certainly have him to blame. So I saw one of his videos when I was in 8th grade and wanted a microscope after that. 10th grade, I did a build of Dan Berard's STM, scanning tunneling microscope. That was a lot of fun. Or was that 11th grade? That might have been 11th grade. Yeah, that was 11th. And then senior year, my eBay alert. So I set up an eBay alert pretty much as soon as I could, and that sat there for years. And I emailed some people who posted a microscope on Craigslist at one point. I wanted one for a while, and then an eBay alert popped up for a ISI Super 3A that was like 2 hours north of me, and maybe 3 hours north, for $400, and I was like, that microscope is mine now. So then my dad and I drove the pickup in a trailer up to pick it up, and I got there, and it was not as described. It was the pictures were of a complete functional microscope. Oh, that's a very satisfying sound now. So yeah, picked up that microscope with it was not as described. The picture on the eBay listing was of it on a pallet, fully assembled, and then when I got there, it was completely taken apart and in this guy's wood shop, and like the column was just like sitting there open, like without the like cap on it, and it was just like full of sawdust. So it was like almost in as many like, I mean, it could have been in more pieces, but it was in a lot of pieces. So I was like, oh, that's gonna be fun. But I was not deterred, and so I got home and just started putting it together. And it took me months to get that system going. Like, there was some fires involved. I put that piece on in the wrong order. That piece actually doesn't go in. The next part is to put the coil contacts in, and then this holds the coil contacts in. Yeah, they did the I used the photos when I got it originally trick. And the guy actually, so it was an ex Boeing microscope, and the guy also used to work for Boeing. He traded an optical microscope for the electron microscope, which I thought was kind of funny. But yeah, it was a little bit more work than originally I thought it was going to be, but it was well worth it. So I did that one, and then it wasn't exactly a barn find. It was this guy's like wood shop, but it was in his garage, you know. He had built a bunch of like wooden stands for parts of it, so that was kind of convenient. But he got it taken apart. He never put it back together. So yeah, did that thing, got that one working, and then on the microscopy listserv, which is an amazing resource as well. There used to be a surplus equipment page. It was like a PHP page, so it's not exactly there anymore. Well, just because like Nestor hasn't maintained that page. But somebody posted a Joel 35C, and then it disappeared, and I was like, oh no, I actually wanted that, but I still had his email because I had like started drafting an email earlier, so I emailed them. And they're like, yeah, we do actually have it, and yeah, we will just give it to you. So I went and picked that one up, and that lab turned out that they had 5 other TEMs, and they're like, oh, you kind of know what you're doing. I'm like, no, not really, but you can, you know, I'll work on your microscopes. So I worked on their microscopes for 2 or 3 years. I think like 2 years total. As employee of that company, kind of as their in-house service engineer. Actually, no, it was less than 2 years, I think. I ended up contracting for them afterwards. But yeah, so I maintained all of their TEMs, and then while I was there, one of the like hired engineers came in, or like the engineer they hired for their Joel TEMs came in, Joe Bricker, and I was like, how much do you make on this, you know? And he was like, oh, you know, this much per day, and it's like, oh, that's like 8 times what I'm making per day. So it was like, you can make money doing this, interesting. So then, yeah, started doing field service, relocations. I did relocation for that company while I worked for them, helped them acquire a TEM, and that was my first like flyaway, like fly somewhere, take apart a microscope, put it on a truck, meet the truck back in Seattle, reassemble the microscope. And then, yeah, just kind of kept going. It's been a lot of fun. I enjoy working on TEMs a lot. They're tall electron microscopes or troublesome electron microscopes as compared to SEM, which are simple electron microscopes. That's according to Joe Bricker, and Joe Bricker jokes that he doesn't even know how to spell SEM. He only knows how to spell TEM. You know. Yeah. He's pretty cool. He worked for Joel for like 25-something years. Yeah, he just works on certain vintage Joel SEMs now, so. Anyways, I got some more cleanup in this box I got to do still, or want to do. Here, we'll reset up our camera for working on this box. Hello. Let's see here. This is going to have to go this way. This is not a basement workshop. This is I'm actually like about 1.5 feet above street level. That is the street right there. You can kind of see across the street to the bar across the street from my workshop, so that's great. That's also a new addition. Let's see here. This is all tangled up right now. But I have a neighbor. I have a neighbor whose forklift I borrow because I have my loading dock is about, you know, yay high-ish. It's like the perfect height to back a pickup to, but a little bit annoying to get microscopes up and over. So I yeah, borrow my neighbor's forklift when I need to. He's really cool. And then yeah, I got another like I don't know, 1,800 square feet of workshop back that way. But that part's kind of full right now. This is the studio, so we're filming up here. Okay. Don't need that chair anymore. Be gone. Let's see here. Let's expand the legs on this tripod. I don't think I need these legs all the way out like I got them, so I'll pull one set in. Yeah, when I was looking for a workshop, I didn't want a basement workshop. I work in a lot of basements, and they're very dark, and I like the sun. So I walked into this place, and it had windows, and there was sun, and I was like, that's great. I like that. It is a slab floor. That was another criteria when I was looking for a workshop, was that it be a slab floor. That was very important to me. I wanted a slab floor, ground level. And most of the ones you find are basements. This one was not, and I was like, that's cool. So I think we're gonna probably be wrapping this stream up soon. My next step on reassembly here is a little bit annoying. I need to, there's still some goo on some of these cables, and there's still some duct tape or whatever it is on some of these cables too. And I need to take said duct tape off. And you know what? I don't have it in me to do more cleaning of this goo tonight. And I got some more goo I want to clean out in here. So I think we're going to start up the next stream with de-gooifying and doing assembly. This SEM is a, I want to say it's a, I can't remember right now if it's a 2011 or 2014 model. Let's see if we can find some dates. It's a 2011 model. This is a Zeiss Merlin. It's a good platform. It's a really solid platform. Pretty easy to work on. I like the electronics layout. Grounding architecture is excellent. A lot of cooling. Very few expenses spared on this platform. It's pretty good stuff. It's got a really good stage. Some Zeiss microscopes have stages that I don't think should be on a field emission SEM because of rigidity issues and vibration issues with them. But this one's a lot more solid. It's got pretty nice isolation, air isolators. So yeah, it's a good platform. What is around the corner? I can show you a little bit. If you want to get a really good sense of what's around the corner, check out the end of the series of live streams I did on installing the cooling loop for this microscope. It should be the live stream right before I started doing this series of live streams. And at the end of that live stream, I kind of do a little bit of a studio tour and move the camera around some. But yeah, we can see if I got the cable links to wander over there real quick. I've moved more microscopes in since that live stream. So it's a little bit packed right now, and I need to do some organizing of it, but oh, we're losing the USB-C connection or the battery. I think it's just the connection. Yeah, there we go. Okay, so around the corner we got some chillers, some stuff in the hallway right now, but yeah, that's the rest of the workshop back there. A little bit packed right now. That's my bow truss roof, which I love. And then this is kind of my microscope part cleaning station at my one sink I got. So that's my RODI system. And yeah, so that's kind of the rest of the shop. We'll do more streams from back there later. You can see there's 2 SEMs you can see in there. It's kind of hard to make out the column on the one in the middle. The foil's on the cold field emission one, and then in the middle there's a thermionic tungsten, which is 6400, and then in the back there's a TEM. And then on the right side, kind of behind a bunch of stuff, there's like 4 or 5 more SEMs. I don't know, what is it? 1, 2, 3, 4. Let's see, 35C, 6400, 7600F, and another Zeiss Sigma. And then up here, I've got another Sigma. And yeah, that's another fun Zeiss. That one's running right now. Well, I know it's not, the vacuum pumps aren't running on it. Well, the scroll pump's not running on it because it's a little bit loud, so I keep it off for the streams because it keeps it quieter. But yeah, that, and then this up here, this is my studio. Oh, that bottle in the sink is my primary cleaning solvent. And I don't drink from bottles after they become cleaning solvent bottles. I don't, because I'm just like, oh, I was using this on my like electronics bench. You know, that's not not an environment I want to be drinking from. So yeah, if y'all got any more questions, now's a great time to throw them in the chat. I'm going to be wrapping this up soon. Hopefully that answers, also, what's that round thing in the corner? Round thing in the corner. Okay, actually, I don't know. When you said around the corner, I thought you meant that corner. What do you mean round thing in the corner? I'm curious. Like, that's, oh, that corner. The other, not the corner to the left, the corner to the right. The round thing in the corner to the right is this microscope scroll pump. That right there is the scroll pump for this microscope. So hopefully that answers your question. So that's like the roughing vacuum pump. So that's a dry vacuum pump instead of an oil-based pump. Yeah. So that's going to be this microscope's roughing pump. So that will connect to this hose right here via those hoses right there. So yeah. Well, I really appreciate you all joining me for this stream. Again, if you got any more questions, what camera did we just, oh, I just blocked the camera, I think. Yep. So yeah, I think we're gonna pretty much wrap the stream up here. If you all got any more questions, you know, feel free to let me know. Let's see what's been going down in the Discords. Those radio codes are fun. Yeah, those handheld XRFs, those are cool too. Okay, oh, you moved to 7330 or 7. Wow, I haven't seen a full-size Joel column moved in the back of a pickup before. Congratulations. That is a first. I've not seen that. Oh, that's the 35C era vacuum controller. Interesting. Okay. Okay, so you're missing the WDS, so you can just blank that off. When you make the blank for your 70 or 733, you make that blank. Make it out of iron, not stainless steel. Stainless steel is not magnetically conductive, and you want magnetically conductive. So this is 35C era. Yeah, that's yeah. That's 30. Okay, so this isn't even 840 era. This is 35C era. Well, this is like a hybrid between 35C and 840 era. Usually the microprobes, so like the microprobes tend, so there's like the SEMs are Joel's like flagship, right? And then the microprobes are developed based on the SEM platform, so their controls tend to kind of be a higher end version of like half a generations before SEM controls. So the 35C, 35CF, that's going to be like the SEMs that kind of your microprobe was based on. So the high voltage cable just goes down to like nowhere. It looks like there's just like an empty spot in the control console. Okay. Yeah, that thing's revivable. You just need to hook it up to something else. But yeah, it's like the electronics are really not gonna care what high voltage supply you use. So that's good. Yeah, you should be able to use a 35C high voltage tank too. A 35C high voltage tank might actually be like kind of directly compatible with the high voltage control module that's like kind of in your control console. A 35 or an 840 6400 tank is going to be a little bit newer, and you have to kind of like do some like separate set of digital controls for that. Yeah, congrats on moving a Joel column via a pickup truck and a ramp. That is an accomplishment for sure. Yeah, 60 kV sounds right for the microprobe. You don't need that high though. Like if you get like an SEM supply that's lower than that, that's gonna be fine. Do you have more pictures of your 733? 733s, plural, I should say. Yeah, you got one of the earlier Joel motorized stage controls. Those are fun. I think between the two of these machines, you should be able to get a relatively complete set of parts. I mean, you don't even like, I'm guessing you're only planning on getting one of them running, so you don't even need to like machine a blank. Just like take one of the spectrometers or take a blank off of your second one and put it on your first one. Or I don't know what your first and second one are. But yeah, that way you can avoid machining a blank. It looks like you're missing a secondary electron detector in one of them, but you've got one on the other one, so you can kind of like, I think mix and match, and you'll get this thing together. Yeah, the HV tank really seems like is what you're going to be dealing with. Yeah, ask for a channel for your microscope in that server. And that will take you a long ways. And then yeah, if you want to post some like close-ups of your cutaways, do you have like the roughing pump box for it and the oil cooler? I don't see it in any of the pictures you posted. It's like a third box kind of. The pump box and oil cooler box. The photomultiplier tube is actually on the outside of your microscope. It bolts on the right side. It's a cylinder that comes off. I'm looking at like the picture in front of the pub with your microscope, and there's the secondary electron detector is sticking out the right side, kind of halfway up the WDS spectrometer, and then on one of the other pictures it's missing there. The phosphor that makes up that is in the front. Is in the chamber. Okay, no oil cooler. Well, you're gonna be building one of those then. That's gonna be a fun one. It's doable. It just basically seems like I think it's basically hydraulics parts. So, there's a website where a guy did pretty extensive work on his 733. Yeah, okay, here's the site. And he's got some pictures of the oil pump and the oil reservoir and the flow switch and everything. And there's more online too, but this is a pretty great resource for your microscope in particular. I'll post that in Discord and in the chat here. The oil cooler is for the objective lens cooling. The objective lens is critically cooled with oil. So a critically cooled objective lens, or a critically cooled lens in a microscope is one that will overheat and damage itself if it loses cooling. And then some lenses are cooled for stability. Some lenses are cooled because they will literally melt themselves. The objective lens in a 733 is very, very firmly in the it will melt itself territory. So that's why it's a critically cooled lens. And it's because as the pamphlet for it says, it combines short working distance, high takeoff angle, and large numeric aperture. So combining those three things together basically means you need a really small, really powerful objective lens. So yeah, the roughing pump and the air compressor, those aren't going to be that big of a deal. Another thing I am thinking about is that the pump box. Okay, it looks like the pump box on this one doesn't have very much AC going on it, so that's to your advantage. They're using the same pump box that the 35C uses, and in 35C they shoved some AC stuff inside of that pump box as well, but it looks like that is not present. So yeah, you've got a couple interlocks signals that are going to need to be carried over from this box to the microscope. The air compressor interlock might be present, but definitely it looks like you have the rotary, there's a flow switch on the oil cooler, and there's also so that flow switch will have to, and you do want a flow switch because if you lose oil cooling, you will destroy your objective lens. So you absolutely need to make sure that's interlocked. And then there's also a sensor on the roughing pump that detects that the roughing pump is spinning, and you can just put I don't recommend doing this long term, but I do know that you can use a function generator to pretend to be the signal from that rotation detector on the roughing pump. Yeah. So yeah, this is a great website. It's got some great pictures. When was this done? Yeah, a lot of good information on here. And then definitely click through his links too, because he's got links to other 733 repairs that he's been involved in. Yeah, looks like he was pretty active on this recently. That's cool. Oh, lost the camera. I'll bring that back. Yeah, a lot of fun stuff to scroll through. The objective lens is at the very bottom. It's the objective menu lens. If you look at that diagram on the page I linked, it's the little tiny lens. It's kind of like an angle. Very small, right at the bottom of the column. Let's see here. So what model do you think the other one might be, if not a 733? I probably have some electron gun supplies, I could say, for whatever I paid for them. They're not SEM supplies. They're just like rack mount ones. If you're interested. Then they just got like screw terminals on the back of them, which is kind of sketchy for these voltages. They won't go up to 50 kV. They'll operate at like 10 and maybe 20, I think. I might have a 40 kV one. I think I've got one of these or something like it. That's a field emission one. That link is too long. Okay, let's try and shorten that up. I've got a bunch of surplus equipment in one of my storage units, or I have several storage units full of microscopes that I need to get rid of. And if it can help you out with your microscope, I'd be more than happy to do that. Make it not on UK eBay. I'll probably find some better stuff. Yep, definitely finding more stuff on not UK eBay. Yeah, there's a, it's not. I don't have exactly that Kimball Physics one. I don't remember exactly which one I have off the top of my head, but yeah. There's also the 2LE. Let me see if any of those are out there right now. I've given away so many of those. I am not in the UK. I just had UK eBay open for some reason. I am here in Portland, Oregon, so so shipping would just be within the same country, so it's not terrible. But yeah, I'm pretty sure that I or one of my friends has got a supply that we'd be willing to part with, basically for the price of getting it shipped and packed is really what's going to be annoying, but because it's pretty heavy, or they are usually pretty heavy. But yeah, that should definitely be able to get you online, and then you can basically just like put your cable in like a box, and then just like make the connection in the box, space them, 1-2 inches, ideally probably apart, and then fill that whole thing with epoxy. That's a pretty good way of doing repairs on cables like you've got. So, in fact, if you're going to replace the supply, you already need to cut the end of the cable off. Or an easier way of replacing the supply is usually just to cut the end of the cable off. So, yeah, there's a pretty wide variety of electron gun controllers that you can make work. You just want one that's going to be stable enough for your microscope to work well. But yeah, if you got two columns, 2 control consoles, I'm guessing, you're set up with parts. You're doing great. So yeah, just find a supply, and you shouldn't need much else if you can just like move stuff back and forth between between the microscopes, and just plan on ending up with one working one, and yeah, you should be good to go. See, are there any 2LEs? Are there any 2LIs? Only one console? Okay, it's still not that bad. Like the console's mostly analog electronics. Yeah, no, that's an electron gun supply is one that like has like the filament supply. So that they got the isolation transformers. They're floating the supply. Like they're exactly what you would need to power the filament too, because the filament power supply has to be floating on the gun power supply. Like if if it was just a high voltage supply, I'd call it just a high voltage supply. If I'm calling it an electron gun supply, it's got like something to power the filament. Okay, cool. There's some more pictures. Yeah, I think you've got a pretty good shot at getting these tools up. I think you got. I mean, so you're gonna need high voltage supply, oil cooler, roughing pump, and I'm guessing you've got an air compressor already. So yeah, get a channel on the Discord, ask some questions about, you know, what roughing pump you should get, or just find some options for roughing pumps and then ask in the Discord if they're a good option. Yeah, you've got a pretty good set of control cards. It looks like they didn't cut most of the cables, so that's great. Let me see if I've got, I may have some info on a 733. Let me check. Honestly, with these Joels, I've had very, very few bad caps. And that's because a lot of the power caps they used, or a lot of the caps they used for like power smoothing, whatever, they like clamped in like metal rings, so they like have like heat sinks on like every capacitor. Yeah, filaments, you can get like burnt out filaments. Yeah, or yeah, if you don't want to spam introductions, well, you're fine. Just throw it in one of the general chats. Throw it in general, throw it in just throw it in general, and ask for a channel for your scope. Just mention it's a JXA 733, because all the other ones are JSM 733, so you have a JXA 733. Japanese X-ray analyzer is what it stands for. Okay, let's see here. Anything on a 733? I guess that's applicable. It's not really like a 733, but I guess that's the same. Did you get any manuals or docs with your scope? The other thing I'm curious of is where your like AC supply is. I guess the AC is in the yeah, the regulator box is in the column, I think. Yeah. Okay, no docs. That's fun. I think 35C schematics have been posted. 35CF schematics. That's going to cover a lot of what you need because 35CF is going to have a lot of similarities to your system. I don't see any 733 schematics they might have. Well, I got other places I can check for stuff too. I might have something on it. For some reason, I remember having something on it. Maybe it was a JWS. I think it was a JXA. JWS is the wafer systems, and the wafer system, some of the wafer system microscopes have similar. Yeah, all the docs have been posted in the War Thunder forums. Yeah, that'd be funny. Cool. Well, I'll have to check on not my streaming computer and see if I maybe got something else, but yeah. Well, I think with that, I'm going to be wrapping this stream up. The Beryllium window was on. Yeah, the X-ray. Do the WDS have a Beryllium window? I don't know. I know that the silly or the EDS, energy dispersive spectrometer, that may have been on the front of your system had a Beryllium window. I'm not sure if the WDSs have a Beryllium window on them or not, but a lot of detectors do. I just don't know if those WDSs do specifically. So I'll tell you what, the guy who's got that website, I bet he's a great person to reach out to. Because I bet he's got some docs. In fact, I think there was a picture of the schematics like on his site. So I got excited for a second. There was a 733 manual on archive.org, but it's one that somebody's made. It's not the official Joel one. Yeah, I think there's a guy in Seattle who's got one too, actually. There's actually a fair bit of info out here on this. But yeah, beryllium is a good one to be. Beryllium is a really good one to be careful of. Yeah, especially if it makes beryllium oxide. If it gets wet, it'll oxidize, and you get this white powder. Like the window itself, as long as the window itself is intact, it's okay. If the window breaks and you have small pieces of beryllium, that's bad. If you get water or moisture that condenses on the beryllium, then it turns into beryllium oxide, and that's a white powder, and that's really, really bad. That's when you start to get more issues. Beryllium oxide, I think, is water soluble, but it's just like a white powder that forms on the surface of the detector or on the surface of the windows, and it's like, and it just wants to fall off. It's great. It's amazing. I love it so much. I've had very late nights cleaning up beryllium oxide, and it wasn't my fault, but I discovered it, and therefore it became, I felt like it became my responsibility. I probably could have passed it off to somebody else, but you know. I don't always know when to make things somebody else's problem. Oh, okay. There's a link on the 733 website that is scan 733 manuals, and you have to request like access via the Google Drive link. But I would definitely do that because I bet they've got most of what you need scanned in. Well, good news. The 733s, the Joule Microprobes has like got a pretty dedicated community that surrounded them of users and facilities, and I know that people like answering questions and like sharing resources. So emailing the folks that had it at Caltech, emailing the people that's got them at University of Washington. I think there's a guy in Seattle who's got one just like in his house, basically, and he runs a business off of it. And then, yeah, the guy who's got this website online. Like the MicroPro community likes to support each other. So I would, I think you're in a pretty good shape to reach out for some resources and get some assistance when you need it. Well, yeah. Yeah, White Quark is really cool. White Quark has White Quark is the reason the Open Beam Interface project exists, like at all. She helped write a lot of like the core like software and gateware for that. She came up with the entire architecture in like 3 hours. It was like magic to watch her figure that whole thing out as quickly as she did. Yeah, what she came up with is some really, really great stuff. So I definitely look forward to working with her more. Yeah, flow rate is important, right? But flow rate's a function of pressure, so it's basically you need to know what pressure of hydraulic pump you're looking for. The pumps can be specified in terms of flow and like how much flow it can provide at what pressure, but I think pressure is going to be the harder one to find exactly what you need. Yeah, well, I think with that, I'm going to be wrapping the stream up here pretty soon. I want to get off at some point. But definitely look forward to seeing you around in the Discord. Just throw in the introductions chat that you got. It's a 730. It's Joel JXA 733, and ask them to make a channel for you. And then you'll have a place where people can throw resources your direction, and it'll be great. Yeah. Well, anyways, with that, I think I'm gonna bid you all farewell. It's been great having you by. Excited to hear about your 733 project. I really think you can get these scopes going. It's gonna be a matter of finding you that high voltage supply, but I think between me and some other folks, we've got one that'll work for you. And yeah, I'll look at some other docs, but yeah, definitely go to that link on that 733 site and request the docs, and I bet he's got like everything you need. Cool. Well, it's been great having you all by. Look forward to working on this more with you tomorrow. And yeah, I will see y'all later. Have a good one.